Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at inequalities on graphs. Now, let's have a look at the first thing for this video. The first bullet point says, let's imagine we have got a curve and we've got another curve. Now, the curve might be a straight line, we don't know, but for example, let's say we've got one curve, which is f of x, and we've got another curve, which is g of x. If we have the values of x for which the curve f of x is below the curve g of x, satisfy some inequality. So for example, let's say we've got f of x below. Let's have a look at what that looks like on the graph. Now I've got here in my example a straight line and a curve. So f of x is my curve and g of x is, it says here curve, but I've got a straight line just to visualize this. What we've got is f of x being below the curve g of x. So if I do some highlighting, if I get a blue highlighter, g of x is the blue line and f of x is the red line, or the red curve. Where f of x is below the g of x line is, well, on the graph, it's that part there, okay? Because we're looking, if we think about this below the page or down the page, if we think this is down the page, it is below this straight line, we can see it's here, okay? Up the page, this red part that's at the top of the page, we can see that is clearly above the blue line, okay, or above g of x. We want, for this first example, where it's below g of x. So we can see here, okay? That's what we've got there. Now, what is that inequality? What's that going to be satisfied by? Well, it's going to satisfy this inequality, and satisfy just means make it true. It's going to say f of x is less than g of x, okay? In terms of the graph, we were looking for where g of x is below. That's this bit here. But what it actually means kind of mathematically is that all the values of f of x are less than the values of g of x in this grey region here. And I'll join them together with a grey highlighter, okay? And that kind of makes sense. All of these values on the graph are less than the blue line, so that should make sense to you, okay? So hopefully that makes some sense. Now, what we now need to think about is, well, let's have a look at a different example, but this time where f of x is above the curve. So we've got, what inequality will that satisfy? We want f of x to be above the curve, so again, we're going to take the exact same diagram, but this time we're not going to shade the same region because we want above the curve. Now that is, again, that's the red graph, and if I get a blue highlighter, that is the blue line. We can see if I highlight this in grey, that those are the parts of the graph. And remember, the quadratic does not stop there, it carries on forever and ever. Those are the parts of the graph, the two grey parts, and it could kind of continue up here if you like, but that doesn't look too neat. Those are the parts of the graph where we have f of x being above g of x, again for the reason that it is above the page, it's on a higher part of the page if you like than this straight line, and so that works out for the graph. Now, what inequality does that satisfy? Well, we want f of x to be above, so what that says is, and we could write it the other way, that f of x is greater than g of x for the grey section of the graph, okay? Here we had f of x being less than g of x there. Here we've got f of x, which remember is the red curve, being greater than g of x, okay? So the more practice and the more examples you do with this, you'll be able to see straight away which part of the graph is greater or less than another graph, in this case the straight line. Okay, so let's have a look at an example. Again, I've got a straight line and a curve. The straight line has this equation, y is equal to 12 plus 4x. And the curve has this equation. It's just our general quadratic, y is equal to x squared. The first thing we want to do is find the coordinates of the point of intersection. So it's where these two graphs cross. We can see that is there and there, so find what those coordinates are. And then part B says write down the solution to this inequality. And we can see what I was just explaining here. We want the straight line to be less than the curve. Okay, so have a think about that. So pause and have a go if you want to, and then we'll work through the answer. Okay, let's have a go. Let's see whether your answer was correct. So part A, the first thing we want to do is set the two graphs equal to each other, because where they cross, it means they are equal. So 12 plus 4x is equal to x squared, okay? I'm then going to get, well, the right-hand side to be equal to 0, but I'm going to take these two terms over this side and then just write it the other way. So I'm going to have x squared, and I'll just do a little arrow, x squared minus 4x minus 12 is equal to 0. Then I'm going to factorise that. Hopefully you're confident with factorising now. That's going to give me that. X minus 2, x minus 6, and you can check that by expanding the brackets, and you'll see that we should get this quadratic like we had. Okay, so it's equal to 0, and then we can just say, well, either bracket can be equal to 0, so that tells me that x is minus 2, or x is equal to 6. Okay, so we've kind of got half of our answer now. This is our two values for x, the point of intersection. So what that means is at that point of intersection there, well, x is positive, so x must be 6. And at this point of intersection there, x must be minus 2, okay? So we've got our values for x, we need our values for y. Well, let's go back. We have got two options here. We've got a straight line, and we've got a x squared curve. All we need to do is substitute our values for x, that we've just found here, into either equation. Doesn't matter because they're the same, okay? They're the same at these 2 points. I think it's easier just to square our x values, so I'm going to substitute into y is equal to x squared. So y will be equal to, well, when x is minus 2, we will have minus 2 squared, which is the same as 2 squared because it's negative, it disappears, so that will give me 4. And when x is equal to 6, we'll just split our working off there, y will be equal to 6 squared, which is 36. And so POI, or point of intersections, are, and we'll write it as a coordinate, we'll say x is minus 2 and y is 4, and the other point of intersection is 6 and 36. Okay, so that there is our final answer for part A. Part B then said hence. It's really important that we sort of take note of the wording of the question. Hence means use part A. Hence is saying, right, you've done something, hence do this. And the hence part means we need to use what we've done in part A to get the answer to B. So B says we want to write down, so we're not really doing any working, we just want to be able to write the answer down straight away to the solution to this inequality. Well, if we, for example, like above, call this f of x and we call that g of x, we can see here what we want is we want where f of x is less than g of x. Okay, and if we look back at what we had up here, f of x being less than g of x, it's a connected part here. We had our straight line, this was the curve, we wanted where the curve was under the straight line here, so we wanted this part. If we look at our graph, we still want the straight line, which we called f of x, to be less than the curve. So if you don't really want to think about f of x and g of x, you can just think about it like this. The straight line being less than the curve is, being less than the curve is this part here. Okay, it's that part there. Nearly highlighted the wrong part there. We want the straight line to be less than the curve. Now here, the curve was less than the straight line, but here we wanted the straight line to be less than the curve because we did them the other way around. So we want this part of the graph and that part of the graph. Okay, now in terms of an inequality, what is that? What are our x values? And I'll write it here. We can see what we want is well, everything to be in this part of the graph. If we think about our x values, here the x values must be less than -2. So x is less than -2. And then we also want, or it also works for the second grey part of the graph here. And again, remember, our graph will carry on like that forever and ever. We want this part of the graph. Here is our x value of 6, because that was the point of intersection. And then we want, here we can see the x values to be over here. They are greater than 6, okay? So, or x being greater than 6. And then there is our answer to part B, okay? So the reason I looked up here and had a look at this was because we called our straight line g of x in this example, and just down here I called it f of x. So you do want the two separated parts there, and you can think about it quite easily. Where the straight line is less than the curve, that's those two parts there, because that's our straight line. Okay, let's have a look at the second and final example for this video. It says the sketch shows the graph of two functions. F of x just means it's a function, and they're two quadratics. X squared minus 4x minus 12. And g of x is 6 plus 5x minus x squared. Part A says find the coordinates of the point of intersection, so that's quite easy. And part B says find the values of x for which f of x is less than g of x. Note here, it wants our answer in set notation. So if you want to, pause and have a go, and then we'll work through the answer. Okay, let's do the final part of working for this video. To find the points of intersection, just set the two curves in this case equal to each other. So, f of x, we'll write it like this, will be equal to g of x at the point of intersections, or POIs. So, if we write that in, x squared minus 4x minus 12, yes, will be equal to 6 plus 5x minus x squared. So we want to basically solve a quadratic, so we can manipulate that a little bit to get this. 2x squared minus 9x minus 18. And we get that by adding x squared to both sides to get rid of the negative here. That gives us, in a minute anyway, when we've added these two, that gives me a right-hand side of 0. So I'm going to take off the 5x from both sides to give me minus 9, and take off the 6 to give me minus 18. Right, then what I'm going to do is I'm going to solve that because we want values for x. So I'm going to factorise. I'm going to say two numbers that times to give me 36 and add to give me minus 9. I can list the factors of minus 36. That is here, oops. That is 1 and minus 36, 2 and minus 18, 3 and minus 12. I'm going to stop there because I can see, well, those add to give me minus 9, and they also times to give me minus 36. So that's perfect. So I can put a tick on there, and those are my two values that I'm going to use. Then when I factorise, I'm going to get 2x plus 3, and I can divide this next bracket by 2, x minus 6. Okay, so that's what I'll get there when I factorise. Then what I want to do is I want to solve. So I want to say, well, that will tell me that x is minus 3 over 2, or x is 6. I get, and I'll do that in red, that from the red bracket and that from the green bracket. Okay, we set each of those brackets equal to 0. Okay, right, so now we've got our two x values that are intersect. Then what we want to do is we want to find our y values. So when x is minus 3 over 2, y, we can substitute it, like the previous example, in either this equation or this equation. I am going to go with this equation because that's what I've done previously. So y will be equal to minus 3 over 2 squared minus 4 times minus 3 over 2 minus 12, and then if you put that in a calculator or you work that out, that is minus 15 over 4. So one point of intersection should have been minus 3 over 2 and minus 15 over 4. That is one point of intersection. And we can see we have got 2 points of intersection. They're there on the graph, okay? And we can see, well, they're both negative on this intersection here, minus and a minus, so that must be that one there. Okay, now let's have a look at this one. From the sketch, we can see, and they gave you this sketch, so it's got to be correct. We can see we're on the x-axis, but we're not going to take that for granted because that would give us y equals 0. We're actually going to have a look whether that's true. So, when x is equal to 6, we have y being equal to 6 squared minus 4 times 6 minus 12. That does give you 0 because we get 36 minus 24 minus 12, and we can see that that does give me 0. So the next point of intersection is 6, 0. So that was part A, and then part B, what we wanted to do was find the values of x for which f of x is less than g of x. So if we think f of x is our positive quadratic, so we'll just underline that in blue, that's f of x. And in this red colour, that can be g of x. So g of x is that there. Okay, so that is g of x, not the neatest there, but it will do. And that is f of x. Now we want where f of x, so where the blue graph, is less than the red graph. Okay, this is blue, and that is red. So what we want is we want this part of the graph, okay? We want that part because that is where the blue graph is under the red graph, and we can see that there, okay? So I'll do part B just here, and we can just write down our answer. If I just actually get rid of, and I just want to get rid of that, we can see that a little bit nicer. Our intersection, and I'll write it in orange, is, what was it here? Minus 3 over 2? Yes, it was. Minus 3 over 2, that's x, and here x is 6. We want this part here, the grey part, because that's where we've got f of x being less than g of x. That part there is between these two extremes. So what we're going to have is minus 3 over 2 is less than x, which is less than 6, okay? Then there's one final step. We just need to give our answer in set notation. So to do that, we're just going to write it like this. The set containing x, such that is what our colon means, such that x is, well, minus 3 over 2 is less than x, which is less than 6. That would be your final answer for part B.